Hello everyone, today is a very interesting video about deep neural network controller. In this video, I will talk about first, what is DNN controller? Second, show you a demo. Third, how to implement it. Four, what are the pros and cons? First, what is neural network controller? So neural network controller will take some observation as input and output some action. The observation states would be velocity, Euler angles, position, and the action would be like thrust, torque, or something. So at its core, the neural network is just a function approximator. So now let's look at the demo. In this demo, I will show you a PID controller and a DNN controller. They are applied to the same drone, and I will test them under different wind level disturbance, following the last video. This is the structure of the neural network controller, and this is the structure of the PID controller. So let's look at the demo. The first row is the left one is the PID, the right one is the DNN, and they are under wind equals 5 disturbance. Watch carefully about this Z position. The Z position should stay at 1, okay? And because of the wind disturbance, so they will oscillate a little bit. The next row is wind level equals to 10. Okay. Here you can see that for the DNN controller, it can still hold its position from 0.9 to 1.1, but for PID controller, it will move to 2 or even negative. Okay. Okay, and these are the plot of the PID controller and the DNN controller. No wind and wind equals to 10. So here you can see the big variation of the PID controller. Third, how can we implement a DNN controller? So from the MATLAB website, there are tons of tutorial about implementing a deep neural network controller or reinforcement learning controller. But I think there isn't any project or tutorial about using the neural network on a 6-stop quadcopter drone. So this is the purpose of this project, to use a deep neural network to control the altitude of the drone. Okay, so here you can see the structure is the same. Left part is the reference and the error. The right part is the 6-stop 610. And the only thing that is different from the previous project is now we are using a neural network controller to directly generate the thrust command. Okay, so basically it is the same, just replacing the PID controller with the neural network controller. In the neural network controller, there is an observation block and a reward block. Okay. Observation is the states that you are going to feed into your neural network controller. So here I use the error of Z, the velocity of Z, and the acceleration of Z. Next, you need to build the neural network. Okay, there are several types, so you need to have a basic understanding of neural network. Third, which is also the key point, is to craft or design a reward function. I think of reward function as when you teach a student, you need to guide them, right? You need to give them a clear path, okay? When are you following the path, and when are you diverting away from the path? You need to have a clear direction for them. So this reward function is the direction for your drone controller. And I will briefly explain the reward function I use here. Here I use a tracking arrow. Okay, whenever its arrow is large, it will penalize it. Second, I use a thrust change penalty. So if the thrust changes too fast, or the value of the change of the thrust is too large, then it will penalize it. This 0.25 is a constant life reward. So if the drone can stay alive in the boundaries of 2, then it will give it a reward at every time step. So remember, this reward function is the reward for every time step. Next, you just need to train it, okay? And if things don't go right, then you should go back to 1, 2, or 3 and to change something. This is a short footage of probably the 80% of the training process, okay? So I recorded every 2 hours. At the beginning, you can see that the DNN controller tries to use the bang bang high frequency control. So its thrust is banging up and down, up and down. This is impractical, okay? But after I add a thrust change penalty, you can see that as the deep neural network controller learns, it will start to use as little change of the thrust as possible. Therefore, you can see that at the end of this footage, the thrust doesn't change a lot. Okay. Last, it's what I feel or what I discover when I do this project. So I wrote down some advantage and disadvantage of the DNN controller. I just want to share with you. Okay. Thanks for watching.